My name is Douglas Pye. I'm an electrical engineer. I've been part of the FSN for, I don't know, not that long, probably 5 years. I wasn't counting. Like I say, I haven't been present in the last couple of years because I've been very busy. However, Peter was a friend of mine and he asked me to host this meeting, and I readily agreed because he's for him. So, you all should be aware of the topic having signed up, but I'll give you a little, just a little of the abstract. And thank Kabir for his warm-up question because it was kind of related. Today's world is faced with a growing range of increasing planetary scale threats to the environment, the biosphere, and humankind. Climate change is the most widely discussed of these threats, yet it is only one of 9 interrelated planetary scale disturbances triggered by human activities over the past 2.5 centuries. This webinar will explore the emergence and practicality in viewing the Earth's planetary system through the lens of these planetary limits or boundaries. The framework is based on scientific evidence that human actions, especially those of the industrialized world, have become the main driver of global environmental change. The implications of crossing these limits, as well as the timing and interdependencies among such crossings, will form the basis for discussion in terms of addressing these future threats. I did look through the presentation. I did not read it because I want it to be as awestruck as the rest of you, but it's very meaty, very lots of information. And I think you'll really enjoy it. I can't think of anyone better than Peter to give this presentation. It's very timely and relevant. And I'll just give you a little about Peter. He is the chair of the FSN. He has a background as a scientist, business manager, entrepreneur, domestic and international bureaucrat, executive, diplomat, management advisor, and academic. He's affiliated with both the Telfer and the Faculty of Engineering at the University of Ottawa. He is a pioneer in the commercialization of AI, and today is actively involved in ethical and policy issues related to AI, especially as a member of the IEEE USA Artificial Intelligence Systems Policy Committee. Peter has an extensive background on the forefront of scientific and technological breakthroughs around disruptive technologies and their impacts on society. And somewhat relevant to today's topic, his scientific career included working in paleoclimate studies based on ice core and radar data from polar ice sheets. He served as chief glaciologist at the World Data Center for Glaciology at the University of Colorado in Boulder, where he was involved in the development of the concept of nuclear winter. And he is an active member of a US-Canadian partnership among some 24 scholars that are active in developing use cases on the implications of climate change. This group is a spinoff of Sigma Psi. So as I said, I think Peter is very well positioned to give this talk, and I'm really looking forward to it. So thank you, Peter, and over to you.
Well, thank you, Doug, for this introduction. And thank you all for joining us today. I hope you find this interesting, and I'm looking forward to a stimulating conversation after I present a few slides. Perhaps I'll start with the very cover here, the first slide. I'm not convinced yet that we're at the kind of a boundary that's going to transition that quickly between green and desert, but we're certainly, forcing our planet into a variety of situations that could lead to this as a dystrophic view or a future of our planet that is not very favorable to the way we've come to enjoy living. So let me begin this slide deck. Here is, you've had a chance to look at this. This is the basic outline of what I want to talk about. And it's very straightforward. The main thing I'm going to say here is, in summary, that I'm dealing with this concept of planetary boundaries, which has come about in Scandinavia, actually, some research institutes in Scandinavia, particularly Sweden and Finland, and spread across several other centers in Europe have been promoting this. It's now spread to North America as an exercise of deep thinking. There are basically 4 models, as I characterize it. The first one was proposed in 2009, and the latest one I will present here is 2020. So that's kind of where we're at in the context of this modeling, and I'll explain all these in a few more minutes as to what we're going to get into. So here we are setting the stage. The stage is very clear. Climate crisis cannot be addressed as a standalone issue. That has, of course, had a lot of news in the last few days with COP27 in its final day today. They may actually extend into the weekend for some further discussion, finalizing of a united statement for the event. But the climate change is part of a much larger systemic problem, which encompasses multiple processes. So a new word that is now being bandied about is polycrisis. And I would suggest that this is exactly what I'm talking about here today, about a polycrisis, at least a polycrisis on planet Earth.
Yeah, Peter,
And humans are on a collision course with the natural world. And perhaps time will tell, but this recent pandemic may be an example of that collision. Typically, that's where pandemics have come from, animal interactions with humans, and some kind of a crossing that is generally because we're alien to that animal world.
Yeah, Peter.
And humans are on this collision course, and we're now at a point where it seems in many directions that we're exceeding the regenerative capacity of the biosphere. And of course, the biosphere and climate and the water and all these things that are going to be part of this mix, they're all interrelated. And clearly, they're also interrelated in very complex, nonlinear ways. And so we're dealing with processes that we still don't understand in great detail. And we certainly don't understand how many of these things interact over various time frames. So it's going to be a pressing issue going forward. That's an early introduction to this. And consequently, Earth is losing its resilience to deal with stress and disturbance at this stage. Now, the first climate emergency, that's a term that's now in our media and people use it probably even in school. The first climate emergency started with a local government, and that was in Melbourne, Australia in 2016. And just to give you an example, since that time, over 2,100 local governments in 39 countries have declared climate emergency. And that's as of just really early, a few months ago this year with data. And then in 2021, there was an update on the climate emergency declarations. And this was an analysis that looked into some of the components of it. And they identified 31 planetary vital signs that had a variety of issues that are going to be accumulated into what I will discuss. And I just provided a list of those here. But many of these vital signs are incorporated into the framework that we're going to talk about here on planetary boundaries. And as you probably can have heard, I call this limits in the title to differentiate it from the just one model theory, which is called planetary boundary. Sometimes you hear the term tipping points as well. So somewhat limits, tipping points, and boundaries are interchangeable in the context of what we're talking about here. You'll also find that virtually all my slides have some kind of a reference point with respect to a website that can be drilled down and get more information. So world scientists, 1992 was a rather special year in terms of the world coming together about the environment. That was the famous Rio conference. And prior to that, 1,700 scientists signed a document that basically is what it states in the red. I don't need to read it, you can see it. Of those who signed, it was almost every living Nobel laureate who had won a Nobel Prize in the sciences was among those 1,700. Because it really was leading scientists. And that was then. It's even growing more so because there's now the second notice. And that second notice is being a little more bold. For example, third bullet down. Moreover, humans have unleashed a mass extinction event. Somebody, I think it was Shane, mentioned extinctions. The sixth is roughly 450 million years. The sixth in roughly 450 million years. That's certainly since the Cambrian. With many current life forms being decimated or going extinct by 2100 in terms of the forecast by bioscientists. So advancement of urgently needed changes in environmental policy, human behavior, and global inequalities are still far from sufficient. And this, of course, is where we now face things like some of the aspirations in the United Nations Sustainability Development Goals. So in 2017, 15,000 plus scientists signed the second warning. And it dealt with these topics that you can see there. And I might point out that it was the most scientists co-signed a formal support on any scientific journal article ever published as of up until this day. with over 17,000 signatures. So another update came in 2022, and here is the bullets that basically are the main points that were raised in the 2022 update, with the bottom line being humanity is not taking the urgent steps needed to safeguard or imperil our biosphere. So we are really facing a number of very complex issues. This is a well-known principle that I'm sure you've all heard of and probably some of you worked with. It's so-called the precautionary principle. The details here are for you to read. The main thing is it's basically a policy that was developed to protect human health and the environment in the face of uncertain risks. And in the Rio Declaration, again in red at the bottom, you can see what was the consequence of that first major UN effort to gather the world together and come up with a framework to say this is the problem we have to deal with. So how did we get in this situation? I'm sure there's lots of answers, but how do we get out of it? That's another issue. Well, let's start with the big picture. I'm going to reference much of our context to what we call the Holocene. The Holocene is a geological term for a geochronological term for a period of Earth history, and it is the time since the end of the last ice age, or the last major continental glaciation, because the ice age is still coming over cyclically. So that's about 11,000 years. And the Pleistocene is a period before the Holocene. Actually, it's about 2.5 million years of length. So it goes further to the left of this 100,000 year period. What I'm showing here, though, is that this is a variation in temperature of the planets as revealed by various aggregate testing of ice cores and tree rings and ocean cores and various things that give us proxies to temperature variation. They're very physically well established as to how the temperature can be interpreted from these things. So we can see some human activity with the arrows as to different things that happened at different points in our history to getting us to the beginning of agriculture in the Holocene. Before that, we were hunter-gatherers and living in a very almost typical state of like animals in the bush today. And since that time, we saw, of course, the rise of the great European civilizations, the Chinese and Indian civilizations, and others in the Southeast Asia. But all that happened in, relatively speaking, the very recent past. So let's now move to looking at the big picture in respect to, oops, sorry, I didn't mean to do that. Looking at the big picture relative to the ecology and the social foundations we've created. So this is kind of a beginning of the thinking in terms of a diagram that has led to this idea to create this planetary boundary framework. So in the inner circle, we have all these social foundations and the things that are part of our now sophisticated society, which varies, of course, in equity across the world. But we can see that these are all common things of aspirations to all people. And there's a safe zone in that, in both under and over. And so we're in this nice safe space that has been with us during the Holocene, but it's now being forced by change, some natural, but primarily human triggered disturbance of natural systems to be challenged. And so we now have in the outer circle ecological ceilings. And these are some of the things I'm going to be talking about within the framework of boundaries. Framework. Well, it's the normative component of the framework. I'm just reading this, of course. The normative component of the framework is that human societies have been able to thrive under these comparative stable conditions we've had in the Holocene. And in particular, since the rise of agriculture and community and cities, civilization, and so forth in the last 6,000 years. And the framework has been designed as a kind of a conceptual way of appreciating in picture form, if you like, rather than staring at tables of numbers, in picture form, how things integrate and are interrelated. And so it shows how humanity is stressing the entire Earth system, or Earth systems for that matter. So the boundaries for the biophysical processes that determine the Earth's capacity for self-regulation, and if these are crossed, they can generate unacceptable environmental change. And this is the forecasts that vary in severity, of course. And one of the critical ones that the globe has tried to address is the 1.5 degree C warming that is a consequence of our use of fossil fuels. That seems to be going to be now overshot. It could be overshot by up to 2.5 degrees, and heaven forbid even more. So this is a burning issue as to how we're going to continue to keep this temperature down, and ultimately reduce the CO2 and greenhouse gas content of the atmosphere that we have put in there from its old resources that have been stored in the earth. So let me, I have to move something around on my screen. So the boundaries are associated with these, with what we call control variables. So there's a reason how this is mathematically linked, if you like, and linked to data. It's through control variables, and I'll give you some better examples. I'll give you some examples in a few moments. But they're being used to define as a measurable parameter that is causally related to the specific boundary. And so the position of these planetary boundaries are set at the lower end of the scientific sense of uncertainty. So in other words, it's trying to take a view that this is it's the worst case we're going towards, but this is the least damaging of what we're disrupting. Just in order to appreciate, if we get out of control, how much further it can get bad, so to speak. So crossing planetary boundaries becomes a serious risk for abrupt environmental change. Maybe like the picture I had on the front opening page of this presentation. To the extent that these Earth system process boundaries have not been crossed, they make or mark the safe zone for human society. But if we cross them, when we go into an unstable situation. So transgression on one or more of these boundaries may be disastrous or even catastrophic. And let us now figure out what these 9 boundaries are. Here we have a list of those boundaries and a little bit of example on the right of each. Of these 9 boundaries, there's one that has an excellent example of what we can do. And it's got a name. You probably all know the name, but certainly I'll repeat it here, the Montreal Protocol. The Montreal Protocol, as you will probably know, dealt with the reduction of the ozone zone. And so how to rebuild the ozone layer, the ozone, so that it would not be the hole that was so shockingly discovered in the mid-80s by British scientists in Antarctica. So that's stratospheric ozone depletion. The Montreal Protocol has got a world changing on how we can address that. It's man-made chemicals that were causing this problem, and we replace those chemicals with a variant that's far more benevolent to the environment. Other areas, though, that are increasingly becoming close to a boundary is ocean acidification, because carbon dioxide makes carbonic acid. And so it's a weak acid that's forming in the ocean. So those are the topics. There's something called novel entities. This I'll go into a little more detail because it's an evolving term. But novel entities basically are things that we have created that are causing massive pollution problems, such as nanoparticles, plastics, and things of that sort. This next 3 slides is just for your edification should you wish to study this a little further. I've just simply provided a background to each of the 9 boundaries on these topics. So we have some current constraining assumptions. And I think we need to address assumptions as a fundamental issue. We're going to talk about any model or anything. So the exact values chosen for boundaries are somewhat arbitrary. I mean, this is scientists who have been discussing this now for well over a decade, and the boundaries move back and forth a little bit, but they're basically consensus now oriented. Some of the indicators are a bit of these control variables. They're also somewhat subject to arbitrary choice, but we've chosen them with thinking that they are an indicator of the boundary issue. And CO2 is a good one as an example of that. So what is the ideal CO2 concentration? Pre-industrial was around 250 parts per million. We're now at 415, pushing 416 parts per million. Ideally at 360 maybe, that could be a fairly modest reduction, and that might be an ideal kind of climate environment. But what is it? That's still a challenge to decide. But certainly 415 is getting high, and that direction getting bigger is not good. It's not good on the planet. And there's no consensus yet among the biosciences. There's people who study, in fact, life forms, and we always know that there's a continuous extinction and appearance of new life forms, the discovery of new life forms on our planet. But there is a background extinction rate, and we're seeing that as accelerating in the past few decades. And the issue is what is a kind of a boundary that's set on where we get really concerned about this? That's still under discussion. And the boundaries can vary globally for a variety of reasons that may relate to geography. An island nation versus a high mountain nation, for example, will have very different kinds of environmental issues. And so local conditions often determine how things like water shortage or biodiversity loss are affected. And accepting acceptable, whatever acceptable means here, limits to processes that ultimately determine our own survival is risky in its own way, in other ways as well. So we need social science to assess some of this as well. And some limits may be easier to balance with ethical and economic issues than others. For example, we have created the nitrogen and phosphorus problem in our environment because of agriculture. But we need fertilizer to, produce quality product for food consumption around the world. So where is the give and take between the production of these fertilizer materials and their impact on the environment? This is another issue of ethical economic constraints that we have to deal with. And many of the Earth's subsystems react in nonlinear ways, as I was saying a few minutes ago, and all of what I'm talking here is clearly a very nonlinear performance. And most thresholds can be defined by a critical value for one or more control variables. So I provide a little bit of example here. You can have, for example, the nitrogen fixation rate and seawater saturation. This argonite is a calcium carbonate. It's one of three versions of calcium carbonate, and very common in the oceans and in the product of creatures that have shells. And so if we perturb these systems, we perturb both in terms of temperature, nutrient supply, and so on. We can provoke various aspects of crossings of these thresholds. And they're linked in many ways to other parts of this 9-component model. So planetary boundaries and their values for control variables, these are either at a safe distance from thresholds for processes with evidence of threshold behavior. Not everything has an actual threshold behavior. For dangerous levels or processes without evidence of these thresholds. So that's another fuzzy area to do a lot of research in. Determining a safe distance from these boundaries involves normative judgments. So again, scientists make these assessments. They recommend, they publish, and it gets into the literature and so on in conferences, but it ultimately gets to policymakers. And COPE25, it's called COPE processes, one of those policymakers kind of learning tools. Now, the scale of planetary boundary processes. Well, I'll just to point out a few things here. It's got 3 columns, as you can see. And under the boundary character, the scale, we have basically processes with global scale, like climate change, ocean acidification. We have processes that are slow, some with unknown scale. And a good example is the stratospheric ozone, because its concentration and its problems that we've experienced were at the polar region. Because that's where that's where the biggest effects and what our chemicals were doing, given the way the atmosphere behaves. And then we have a whole bunch of aggregated processes from local and regional scales. And these are the phosphorus and nitrogen cycles, aerosols in the atmosphere, water vapor in the atmosphere too, of course. And, land use changes, Brazil, Indonesia, Southeast Asia, and more generally, there's a lot of places that are doing a lot of slash and burn to traditional forests with rather limited soils, but because of their tropical nature. So we have a lot of issues emerging in land use and land use change. And of course, we've mentioned biodiversity. I'll show you some examples in a few minutes. Chemical pollution beyond even the nitrogen and phosphorus, because those are really part of a cycle where but the fertilizer is an important part of our economy and the food production, but it's chemical pollution I'm talking about here are really the toxic chemicals that have been added to the environment. So this is, I'm not going to decode this particular picture here in terms of understanding all the details and why they're what they are. It's just simply, this is the kind of model I'm going to use. So let me explain. And you can see the orange sections indicate overshoot of boundaries. So if you think about this as a characterization, maybe you have this circle in the center, and the things that are green are where we're certainly in the safe zone. Things that are red is where we go beyond the safe zone. So we're in the safe zone up into a boundary, and then it goes red. So it's sort of like that tree that's half green and half dead. If we're still inside the boundary of the outer safe portion, then we're in a nice place. And as you can see in this particular model, some of these things are still unquantified yet. So this is a work in progress that I'm speaking on. So that's a general, when you see these pictures, that's what you'll get. But here is now some planetary boundary issues in terms of, well, you can see the coding on the bottom, these 4 colored boxes. And this is, again, another way to look at what state we're at in trying to quantify these boundaries. And here is the first published example of this boundary theory, boundary framework. It was published in 2009 by a group published in Nature by a group in Scandinavia. The stylization is changed. You can see that this looks like there's lines of latitude on a globe. Those have been removed since, because they really have no particular role to play other than they show latitude. That's irrelevant now. What's more important are the boundaries that are being dealt with. So you won't see these other lines in other examples, and I will go in as we go into the further models. There's 4 in total here. We just looked at 1. Here is just a table to show you examples of some of the data that's being used. These are planetary boundaries data sources. And you can see there's some proposed boundary statements, and there's some current status. Here, the current status, when this table was created in 2009, it was at 387, probably data from the year before, 2008. So you can see how much we've increased even in the last short period. That's less than 15 years. And it's still going up. Also, because you may not be aware of the Dobson unit, I just indicated here what it is. And a Dobson unit is the measure of the total ozone over every geographic point on the Earth. So that's going to vary between poles. But if you're at latitude 45, above you is some level of Dobson units for the amount of stratosphere goes over. And as I said about this argillite, and it's a carbonate-rich mineral, and it's being used as an indicator with respect to measuring saturation states of seawater. The idea of, let's make sure that we're right, yeah. This idea of novel entities, these used to be called in the first version of the model, these were called toxic chemicals or things like pollutants. But now they changed the name to novel entities, which is somewhat confusing, I would suggest. But these are the things that we have created from natural materials, but these are new compounds of chemistry that have been made by humans for doing certain things. And now they're leaking into our environment in a variety of ways. So that's what this is all about, these novel entities. So to quantify the boundaries for novel entities, this is the topic here. It's human-produced toxic chemicals, physical materials. So physical materials can be nanoparticles, for example. And there are a variety of ways of assessing this, and I will just give you a diagrammatic view of that in the next slide. But it involves an assessment at a feasibility level, then a relevance and comprehensiveness of all the issues that we can aggregate around the problem that we're dealing with. And several complementary control variables are proposed to capture the complexity of this boundary. So this is still, again, a work in progress. Some of them are more quantifiable, such as the climate change boundary, as compared to novel entities. So here, with some little bit of graphic freedom, with this blue whale, perhaps, independent of that, I couldn't eliminate it. So I took this directly from the paper. So that's the web page source. And they explain here the 3 criteria. And I've provided some description. These are for the 3 criteria are for assessment. Several complementary control variables are used. Humanity is currently operating outside these novel entity boundaries, and production and release of large volumes and higher numbers of novel entities with diverse risk potentials are exceeding society's ability to control safely related assessments and monitoring. Safety and related assessments and monitoring. In other words, we're continuing to add more stuff to make the problem worse. And again, I present this as an example of some of the thinking that goes into each of these planetary boundaries. So this is the process for the one on novel entities, to this one of the latest ones to be pushed, because we still haven't established all the framework elements to it. And so I show you these as work in progress and what the scientific community is doing. So in this case, we've divided into 3 side of layers. There's the domain itself, there's a technical domain, and there's an environmental domain. So the technical domain is us, the environmental domain is nature, then there's impact pathways, and there's some control variables that we use to try and understand what we're trying to measure here, and understand that the measurement is meaningful in fact that it is interrelated to other things. So without exploring this in great detail, because we could spend an hour just talking about this, I will leave it to you to study if you wish, but to show you that this is a kind of a process that the community is going through and how they frame steps to try and address the problem we're addressing here. So there's another new boundary that's being proposed recently. It's one called green water. And green water is basically precipitation and water that comes from the ground, as in root water. The concept of root zone soil moisture, that's actually the amount of moisture that you get in a soil at 2 meters depth. So anywhere in the world, you can measure the depth of soil at 2 meters and how much moisture there is. That is a universally accepted measure for this idea of what the root zone soil moisture is. That's for various types of plants. And all of this is relative to, I said, to say this Holocene period, where the climate has been fairly stable over long periods of time. Yes, we've had variations of the Ice Age and so on, but still it's well within a reasonable norm that we can survive as we did. So here's the second model that was put out in 2015. And you can see that most things are, well, 4 things are in effect beyond their limits. So that inner circle, dash circle is the safe zone. And beyond that, we're now into some uncharted territory. And it's clear that by the magnitude of these zones, you can see that there's actually, the coloring again is important. There's the green, the yellow, and they call it the orange. So the green is the safe, the yellow is like a caution, and the red or orange is, this is danger zone. So there's 4, there's 2 in the danger zone in 2015. And the third model, which came out in 2018, was a further refinement. This came from work at the Finnish Environmental Institute. And this has still 3 boundaries that have been transcended. But there's a number that are not yet quantified, even 2018. So where are we today? Well, first of all, as I said before, and I'll repeat, these are based on existing data. So this is not just speculation in the sense of a philosophical approach to it. It's actually based on, the data are telling us a story. We're trying to understand the story. The climate boundary is being forced by anthropogenic climate change. That seems to be a fundamental issue in terms of our climate our climate boundary. The nitrogen cycle is definitely moving to its boundary. Ocean acidification is rapidly increasing. Global change in land use is approaching its boundary. And so in January of this year, scientists concluded in the journal Environmental Science and Technology that humanity has exceeded the planetary boundary related to environmental pollutants, or the novel entities. And then in April, only a few months later, a reassessment of the planetary boundaries for fresh water indicated that it now has transgressed its green water boundary, even with green water added in. So there we are, that green water is terrestrial precipitation and the evaporation and soil moisture, so evapotranspiration, if you like. And we're now at a point where biodiversity is becoming very stressed as well. And the coding here is very simple. The red is it's bad, the blue is it's okay, and the other shades are varying in one direction to go better or worse. And so you can see a variety of bio sources down the column in the far left, and it involves both plant and animal species outside of humans. And the summary of major environmental change categories is expressed here as a percentage of change relative to a baseline. And that the red indicates the percentage of the category that is damaged, lost, or otherwise affected. The blue indicates the percentage that is intact, remaining, or otherwise unaffected. This is explained in some detail at the rest. So the latest assessment now. We've already added 2 in 2022, 2 more boundary crossings. So now we're at 6. And protecting nature is, I guess, the latest assessment with respect to land, biodiversity, freshwater, and nutrients. This is an issue that is part of the climate framework for the Paris Accord. And as you know, the 1.5 is a topic that was set, a measure that was set to achieve, a target set to achieve, but I'm of the view that we're going to end up in the 2 to 3 range at the moment. And there's a possibility it can be still reduced dramatically, but it's going to require a lot of global cooperation and commitment with investment. So the fourth model, that's the latest model. So this is the 2022 model. We've now crossed the boundaries in 6 of these areas. Still some unquantified, and we're still working on understanding those. But as you can see, humanity has crossed from a safe into uncharted territory on a number of rather critical parts of our global system. And I leave it at that. And now let's tie this to the Sustainable Development Goals of the United Nations. You can see in this breakdown, these are the 17 goals in this current round of Sustainable Development Goals. The biosphere is the base, human society, and then our economy, global economy. And you can see which goals are tied to these. And so what has been done by a number of researchers is to map these, and I don't want to go into details here because this is rather complicated, and I show this only as an example of how it is being done, and done so in a graphical form rather than tables of numbers. So the UN Sustainable Development Goals are being mapped here to the planetary boundaries. And the goals are listed on the left side. And you can see the components that relate to the goals that are really related to the boundaries topics are listed next. And then where do they fit within which boundaries, as you see on the x-axis. And even a more complicated view, where the goals are there, the same boundary issues, and where are they at an impact assessment on these planetary boundaries, and then mapping with rather complicated flows, arrows, and flows where they fit. So again, a visual on a very, very complex dynamic image of where the problems are. So in the latest model, the green zone is the safe. The yellow is the new. The yellow is new. As you remember, in the first model, there was no yellow. It was just red and green. So the yellow has been introduced, in fact, primarily for policymakers. If I would suggest, in order to say, there's this period, we're giving you this warning, like the science warning I started with to humanity. They were saying it's kind of like there's a black and white. We're here, but we're going there. Now we're trying to say in these models, well, we're here, we're going there, or we're already there, but there's been a zone we could have acted in, or there is a zone we can still act in to try and reduce or prevent going out to the red. That's basically what we're seeing in this version of the model. So let me end with a few conclusions. The concept of planetary boundaries or limits, as I've used in this talk, is a framework for viewing and assessing the vast range of natural and human-induced changes resulting from our perturbations of the planetary. The current planetary boundary framework has got 9 themes, and I pointed out several additional ones are being proposed. The planetary boundary approach maps to most of the UN sustainability goals. It doesn't map to all of them. It's not intended to. Some of them are not relevant. But most of them are, and that's ones that particularly in the bio and the human dimension of that 3-layered model of the goals. So we must recognize, this is my final point, in our day-to-day lives, and this we don't think about day-to-day. We think about it maybe in a conversation like we're having now, but tomorrow, maybe you think about today, but next week, maybe not. But anyway, my point is, we really, as a humanity, have to get on board this day-to-day idea that are governing our institutions, that Earth will, let me rephrase this, to day-to-day lives and in our governing institutions, that Earth with all its life is our only home. And, the fact that we've sent a rocket to the moon in the last 2 days, yes, we'll have a moon base someday. Yes, we'll go to Mars someday. But our home is Earth, and it's going to be here for the vast majority of humans for decades and centuries to come. Thank you very much. I did compile a bibliography as well. I didn't give all the authors because it's not necessary. You could find everything at the web link.
And Peter,
that is my
will this
last
present-
talk. Thank you.
will this presentation be posted somewhere?
Yes, this presentation will be posted on the Foresight website with the announcement of this talk. And this video of this presentation, including the Q&A, I guess we won't record any more Q&A. Probably it's best idea not to, so people
Yeah.
can speak freely.
Fair enough.
So this presentation will be posted on our YouTube channel.